This question is from GATE 2015 Mechanical Engineering paper, set 2, question number 20. The atomic packing factor for a material with body-centered cubic structure is dash. Now, in order to find out the atomic packing fraction APF, we know that it can be found out using the formula volume of atoms in a unit cell. So the volume that the atoms acquire inside the unit cell having a BCC structure. So this has a BCC structure here in our case in the given question upon volume of the unit cell itself. So atomic packing fraction gives us an idea of how much of the space or how much of the volume of a unit cell is acquired by the atoms in it. Now for a body-centered cubic structure, the number of atoms in a unit cell having the structure body-centered cubic is equal to 1 at the center, 1 complete atom at the center, plus every corner has a 1/8 of a atom. So it is 1/8 into 8 corners of the cube, so 8 atoms. Hence the total number of atoms are 1 plus 1/8 into 8 is 1, so it is 2 atoms. Now we know that there are 2 atoms, so we can find the volume of these atoms by taking radius of the atom be r and its geometry be a spherical geometry. So atomic packing fraction is equal to 2 cells into volume of one cell is 4/3 pi r cube. R is the radius of the spherical atom divided by volume of the unit cell. So if we consider that A is the side of the cube inside which the atoms are situated, we'll have the volume of that cube is E cube. Now in order to find out the numerical value of atomic packing fraction, we will have to either substitute A in terms of R or R in terms of A. We can do this by considering the triangle that passes through the diagonal of the unit cell. So if you consider a bottom face or the top face and take the diagonal and join the opposite corners of the unit cell, you will get such a triangle that cuts the unit cell into 2 halves. So in this triangle, we have 1 is the side of the cube itself. So we have this as A. 1 is the diagonal of one of the faces. So the diagonal of the face will have a dimension of √2a, because in any of the faces, we have a square of A sides A. Hence its diagonal will have the measure √2a. So this diagonal is having a measure of √2a. This is the diagonal that we have taken. On both sides we will have one radius, each a radius of the atom, and in between there is a atom with its diameter passing through that point. So it is 2 times r. That means this complete side of the triangle is 4r. From here we can derive relation between A and R. If you try and derive this, A is calculated as 4/√3 times R. We can substitute this here. Let's do that. So we will have APF is equal to 2 times 4/3 is 8/3 pi r cube divided by A is 4/√3 R. So we can substitute 4/√3 cube into r cube. R cube by r cube gives us 1. What is left behind is 8/3 by 4 cube by √3. √3 cube is 3√3 and 3 can be cancelled with each. So we will have √3 in the numerator. √3. Now 4 cube is 64. And 8/64 gives us 1/8. So this is √3/8 into pi. This is calculated as 0.68. So we have the atomic packing fraction of a body-centered cubic unit cell, that is 0.8. Let's fill in the answer. Atomic packing factor for the material with body-centered cubic structure is 0.68. To learn more about cubic structures, you can refer to the NPTEL video Cubic Structures and Atomic Packing Factors from the course Chemical Crystallography. It is by Professor A.R. Chaudhary. He is from Department of Chemical Science, ISER Mohali. I hope this solution will help you clear your doubt. Thank you.